Okay, so the purpose of this video is to give you a review of how to solve systems of equations using the three different methods, two of them analytic and one of them on the calculator, and that is to help you get yourselves prepared for the semester exam and make sure that it's not too long since you've practiced the solving of systems of equations. So we're going to get straight into it in the interest of time. What we're going to do in the first two examples is to solve some systems of equations using the elimination method, and that's one of the two algebra or non-calculator methods. The object of elimination is essentially to take our two equations, which have got two unknowns, both x's and y's, to eliminate one of the variables, either the x's or the y's, and then that leaves us with a system of one equation with one unknown, which we can then find an answer for. Okay, so let's get straight into that. What we see with our first system over here is that we have 3x and 5x. We also have 1y and minus 2y. And so for elimination, what we're going to do in this case, the most efficient method would be to multiply that first equation by 2. That's going to give us 6x plus 2y is equal to 20. And hopefully what you realize or remember is that what that has now done is it's lined the y's up so that they have the same coefficient with opposite signs. And what I can do now is simply add those two equations. That'll give me 5x plus 6x is 11x, minus 2y plus 2y is cancelled or eliminated, which was the purpose, equals 13 plus 20 is 33. And I now have an equation with only x as the unknown. Divide both sides by 11. And I have the first part of my answer, which is x equal to 3. The next part of the process is to substitute that value back in to either of the equations to find the missing variable, which is y in this case. So I have 3 times x plus y equals 10. I've selected the first equation to substitute back into. It doesn't matter, you could have substituted into the second equation as well. In the place of x, I'm going to substitute in the value of 3 because that's what we found x to be. And now I'm going to multiply by 3 and isolate the y. So I have 9 plus y equals 10. Subtract 9 from both sides, and we get y equal to 1. And the solution to our system of equations, x equals 3, y equals 1. So I'm going to go on and do the second example. It's exactly the same thing, but the reason I've included a second one is because you'll see it's a little more complicated. There is not a single number that I can multiply by to get both, to get either the x's or the y's to line up. And so in this case, I'm going to multiply the first equation by 2, and I'm going to multiply the second equation by 3. And what I'm attempting to do is to get the two y variables to have the same coefficients but with opposite signs. The alternative could have also been to multiply the first equation by 5 and the second equation by minus 2, and that would have got the x's to line up also with coefficients that are the same and opposite signs. This one just slightly less work, and so it's more efficient. So I'm going to multiply that out. 4x plus 6y is equal to 22. Multiply out the second equation. 15x minus 6y is equal to minus 3. And now what you can hopefully see is I've managed to get the y's to line up but have opposite signs. I go ahead and I add those two equations to each other. 4x plus 15x, 19x. The y's cancel out. 22 minus 3 is going to be 19. Divide both sides by 19, and I am left with x equal to 1. And so I have the first part of my solution. As before, I need to substitute that value back into either of these equations. And so for no particular reason, I'll pick the first one. And what I'm going to be doing now is substituting in the value of x equals 1 in the place of x. 2 plus 3y is equal to 11. I need to isolate the y, so I'll subtract 2 from both sides. 3y equals 9. Divide through by my unwanted coefficient, and we have our y value of 3 and our x value of 1, and we have now solved our second example using elimination. Okay, what we're going to do now is move to example 3, where we are again solving without a calculator, and this time what we're going to use is the substitution method. The idea is identical. The purpose of this is to be able to reduce the system from 2 variables to 1 variable and then get a value. This time what we're going to do, and the way you approach this, is you either have to get one of the equations in the form of y equals or x equals. In other words, you have to isolate either the x or the y. And so it doesn't matter which equation and it doesn't matter which variable. What I'll do is I'll begin with the first one. Could also very easily have used the second one. And what I'm going to do for that equation is I'm going to add x to both sides, and that equation can then be rewritten as y is equal to x minus 4. So those two x's cancel. I have plus x minus 4, which I've written over here. You're now going to substitute that entire expression, x minus 4, in the place of y in the second equation. And so when I substitute that into the second equation, instead of y plus 2x equals 8, y plus 2x is what I meant to write. I'm going to substitute in the place of this y, I'm going to substitute in x minus 4, and I now have an equation that reads 3x minus 4 equals 8. All I've done is combine those two terms, add 4 to both sides, and we have 3x equal to 12, divide through by 3, and we have our x value of 4. As before, we need to substitute that that value back in, and this time what you can see is the easiest place to substitute it is into the equation that you already rearranged, because I'm trying to find y. I've ascertained that x is 4. When I do 4 minus 4, I can get my y value, which in this case is y is equal to 0. Okay, so that takes care of the analytic methods, in other words, solving by hand. And what we'll move on to now is a reminder of how to solve a system using the TI calculator. You'll see a graph over here has been provided, and that is of course because you must show a sketch of what your calculator produces in order to get your credit. Okay, so the most important thing when you solve a system using the TI-Nspire is you need to get both equations in the form of y equals, specifically y equals in this case, because the two equations must be defined in terms of x. In other words, you must isolate for y. So in this case, the first example, the first equation has been taken care of already. And what I'm going to do is just rearrange the second equation by adding 0.2x to both sides of the equation, so that I can now rewrite the equation as 0.2x plus 0.4. And so I have both of my equations in the form of y equals, and we can now turn our attention to the calculator, which will help us to find the solution. So I'm going to just bring up the calculator over here. What I want is a new document, and specifically a graphing page. And you'll see immediately it goes to f of 1x, which from our point of view is basically y equals. And so I'll type in my first equation, x subtract, I seem to have my caps lock on, x subtract 3, and if I hit enter, you can see it produces a graph for x minus 3, and then if I want to graph the second equation, I just push the tab button, and now I can enter my second equation, which is going to be 0.2 or 0.2, it doesn't matter how you enter that, 0.2x plus 0.4, hit enter, and there are my two graphs. I'm just going to move the names, the labels of the function names out of the way, because the point that I'm interested in is of course the point of intersection between those two. And in terms of showing work, what you also need is the y-intercepts, and hopefully you realize that the y-intercept here is 0.4 and the y-intercept here is minus 3, because the equation of a line is y equals mx plus b. So I'll remind you how to get those if you want the calculator to do that for you. But what I'm going to do is go to Menu, Analyze Graph. What I'm interested in is the intersection. Pick a point to the left of the intersection, enter, pick a point to the right, hit enter, and the calculator will find you the point of intersection, which is the solution of the system. What I'm also going to do is remind you, if you push Menu and Trace, if you go to Trace and you scroll along and hit, so if I scroll along, you'll see that it highlights y-intercept. If you hit enter, it'll give you the coordinates. Likewise, if I just move up, it'll jump up to give me the other y-intercept, and if I hit enter, it'll label it for me. That's what I would expect to see on the graph, those two labels plus the point of intersection labeled. Okay, and so what I'm going to do is just very quickly take a screen capture of that so that I can save myself a little bit of time and I don't have to redraw those, which of course you would need to do. And I'm just going to do that quickly and move that onto my graph, and that contains all of the requisite information. Move that down and we'll just increase that in size. Okay, and so that of course is what I'd be looking for on your assessment, the point of intersection labeled and labels for the y-intercepts. Okay, and now let's move to our last example, which is a word problem. This can be solved using any one of the methods above. The hard part of this, of course, is you need to set the equation up yourself. And so what we have is an August meeting of the math department. They spend $22.85 for 9 cups of coffee and 11 bagels. We then move on to the month of September. They spend $30.35 for 14 coffees and 11 bagels. And what we've been asked to do is to set up a system. And hopefully what you realize straight away is that C, I'm going to use the letter C, is going to be the cost of coffee. And I will use C as one variable, and B is going to be the cost of a bagel. And my system of equations will be as follows. $22.85 was the total cost for 9 cups of coffee and 11 bagels. And then, of course, we move to the September meeting where we have $30.35 for 14 cups of coffee plus, once again, fortunately for us, 11 bagels. And so the easiest in this particular case of the 3 methods that you could use is, of course, the elimination method. And the reason it's the easiest, hopefully you see, is that our 2 bagel coefficients line up. And so what we're going to do in this case is simply take the first equation and subtract it from the second, or vice versa. It doesn't matter which way you do that. I'm going to subtract those 2 equations because that's going to eliminate the bagel variable. So those 2 will eliminate each other. 14 cups of coffee minus 9 is going to leave me with 5 cups of coffee. $30.35 minus $22.85 is going to leave me with, hopefully if my subtraction is reasonable, I think that's $7.5. So $7.5 for 5 coffees. If I divide through by 5 for each of those, then we are going to get, those will cancel out. And so what are we going to get? 10, 15, or 1.5 rather. So it's $1.50 for a cup of coffee. We now must substitute that back in order to find the cost of our bagel. And so 30.35 is going to equal 14 times 1.5 plus 11b. And then we're just going to solve for that. So that's going to give me 30.35 is equal to 21 plus 11b. 11b equal to, so I'm going to move 21 to the left hand side, subtract, and you should get 9.35, and then I'm going to divide that through on the calculator and just round to 2 decimal places, and I'm going to wrap that up right there before I run out of time. So of course, dividing by 11, divide by 11, and you'll have the answer that you need.